we combined like radicals, but they were already like radicals. We could just look at them and see that they were like radicals. But if you look at this problem, it looks like there's no like radicals because none of the radicands match.
Did I tell you what to do?
What do you think I should do, Kai?
You should simplify.
I should simplify them first using the skills that we learned yesterday. So I would factor 27.
3.
Factor 27. So 3 goes into 27.
9 times.
9 times. 3 goes into 9. 3 times, and 3 is prime. So I have a pair of 3s. So I get to pull out the 3, multiply it times the 4 that was already there to give me 12. And what do I put back inside?
3.
3.
Okay? Do the same thing with 12. 12 is 2 times 6. 6 is 2 times 3, and 3 is prime. So I have a pair of 2s. So that means I get to pull out a 2, multiply it times the 5 that's already there to give me 10, and I put back 3. So aha, these are already like radicals even though it didn't look like it at first. Then I need to factor 75. What's the smallest number that goes in 75?
3.
3.
Goes in 25 times.
Goes in 25 times.
5 goes in 25 5 times. 5 goes into 5 1 time.
5 is prime. So I get to pull out 5
It'd be 5
times the 8,
Yeah.
which gives me 40
40 times square root of 3.
times the square root of 3. So even though at the beginning it looked like I had no like terms, no like radicals that is, they're all like radicals. They can all be combined. So I would have 12
62.
plus 10 plus 40 is 62.
Times the square root of 3.
That's it.
Dude, I love
Easy.
this
I
stuff.
get this stuff.
You got it? Good. So if you feel really comfortable with this, here's what I would encourage you to do to push yourself. See if you can simplify some of these radicals without having to factor. And I'll explain how I do that mentally on the next slide so that some of you can try that.
So fractions are coming soon, right?
They're funny.
Not soon, but yeah, they're coming.
Later, you mean? BZ, I have a question.
Yes.
To be
Can you go back
continued.
that page?
Sure.
Alright. Since you know, you can look at them and tell they're all divisible by 3, and 3 is the smallest number that goes into all of them, would that just be under the radical sign?
Well, not necessarily. What happens though is, I can tell you how I would do this mentally, but let me work the next one that way instead of working this one that I've already done. So let me explain how you can sometimes do this in your head. The goal is to think of a perfect square factor of 45. Can anybody think of a number that's a perfect square that goes into 45?
20. Wait, no.
So what numbers are perfect squares? 4. What? 8 is not a perfect square. 9,
16.
16,
25.
25. I've already listed a number that goes into 45.
9.
9
Oh.
goes into 45.
It's
So-
not the smallest number though.
45, I'm talking about another way to do this, mentally. So that means that 45 is 9 times 5, correct? 9 is a perfect square, so I can pull out the square root of 9, which is what?
3.
3. Multiply it times the 3 that's already there to get 9. And what do I need to put back?
The
5.
5.
yeah.
Now, let's do it the long way so you can see how I'm getting that. So 45 is 3 times 15. 15 is 3 times 5.
5 is prime.
And 5 is prime.
You can pull out
So I got a pair of 3s. That means I can pull out a 3,
3 times
multiply
3
it
is
times the 3 that's there to get 9, and put back the 5. I'm just doing it mentally instead of with the factor.
I thought we only factored.
No. Got to factor all these to try and figure out what you can pull out and what you have to put back. That's what we did yesterday. That's on video, Colt. The turkey noises are Colt Reynolds. So, I would factor 80.
2 goes in 40 times. 20 times. 10. 5 is prime.
I need all the conversations to stop,
You can pull out
unless
2
they are
tens,
math
20.
related and you're talking to me. Okay, so I get to pull out 2 times 2. 1, 2 for each of these. And a common mistake that gets made is not multiplying the 2 things you're pulling out, but adding them. So make sure that you multiply. 2 times 2. So I get to pull out a 4. There was already a 4 there. So what's the new coefficient here? 16. And then what goes back inside? 5. Aha. Then I would do 125. What's the smallest number that goes into that?
5.
5.
25 times
25 times.
5. And then 5's prime.
And 5's prime. So I got a pair of 5s that I can pull out. 5 times the negative 2 that was already there.
-10.
And what goes back inside?
The 5.
They're all like terms.
Yeah.
It looked like none were, but they all are. So 9 plus 16 is 25, and 25 minus 10.
15.
15 times the square root of 5 is my final answer. So I know yesterday there was a lot of questions about why do we need to do this simplification, because sometimes we simplified something and it didn't really look much better than what we started with, right? And I explained why yesterday. With this, it's even more clear why this is good, because I started off with 3 terms and I ended up with 1. It's clear the benefit of that, I think. All right, let's do this one. 20. 2 times 10, 2 times 5, 5 prime. Got a pair of 2s. So
It's
what do I end up writing?
4 the square root times the square root of 5.
You got it. Then I do the same thing with 24. 2 times 12, 2 times 6, 2 times 3, 3's prime. So I got a pair of 2s. So I get to pull out a 2, multiply it times the negative 3 that's there to give me negative 6. And what do I put back? What does it take? What do I put back? 6. I put back 2 times 3. So those aren't like radicals. That's okay. Maybe this one will be a like radical in one of them. So factor 180. It's 2 times 90. It's the smallest number that goes into 90.
3.
It's not the smallest.
2.
2. 90's even, right? If it ends in 0, it's even. 2 goes in 45 times. Smallest thing goes in 45? 3. 3 goes in 15 times. 3 goes in 5 times, and 5's prime. So I have a pair of 2s and a pair of 3s. That means I get to pull out 2 times 3, which is 6, and multiply it times the negative 1 that was already there. And the 5 goes back inside. That means this and this are like radicals.
It'd be negative.
So you get negative 2 minus 6 with the radical of 6?
So these two can be combined. So 4 minus 6 is negative 2, and it keeps the square root of 5. And in this one, there are no like radicals. So it just comes down. And that's
How
it.
do you say that?
Negative 6 times the square root of 6. Or you could say negative 6 square root of 6. Either way. You don't have to say the times.
Oh.
Questions before I do the last one?
Eh,
Any questions?
What's the next step that's going to be harder than
Multiplying them. It's not really harder. It seemed to really confuse my second block. So maybe it's in the way I presented it, because I don't think it's particularly confusing. So hopefully it won't be confusing for you guys. All right, 27 is 3 times 9. That's 3 times 3,
3 is
and
prime.
3's prime. Got a pair of 3s. So I pull out a 3, times the 3 that was there is 9,
And
and I
then 3
put
back
back
3.
3. 48. 2 times 24, 2 times 12, 2 times 6, 2 times 3, 3's prime. I got a pair of 2s and another pair of 2s, so I get to pull out 4 times the 5 that was already there,
So it's 20 plus 20.
and I put back a 3. I will tell you from my experience in second block that the biggest mistake that they made working the ones I give them to work, we're going to do clock appointments next, is forgetting that there was already a 5 here, and that when you pull out the 4, you've got to multiply it times the 5. So just know that that's a common mistake, and don't make it. These are like radicals, so what's the answer?
29 times the square root of 3.
You got it.
Hey, does that part say 18 or 28?
18.
Dang.
You got any other questions?
No,
No,
sir.
sir. I'm going to go to the clock.
Cool.